Hello, welcome to this video. This video is for Accelerated Math 3. We're talking about inverses today. How do you find an inverse from symbolic form? And what we're going to do in this lesson 4-2, we're going to show you how to calculate the inverse for three different types of function. We're going to deal with linear functions, right? X to the first. We'll deal with quadratic functions, x to the second, and cubic functions, x to the third, okay? And we're going to talk about the inverse functions and how you find them. I'm going to split it into three videos, and we'll just focus on one type of function and its inverse in each one, okay? So for this video, part A, I'm going to focus on linear functions and their inverse. So without any further ado, we'll go ahead and get to it. The first idea I want to draw back to the last video is how do we find an inverse of a function? And it's plain and simple. I wrote it right up here. I don't know if you can see this right here. Okay, how do you find an inverse? You switch your x and y. That's what you need to know. This is muy importante, my favorite Spanish phrase, muy importante. Okay, put an exclamation next to that. You got to know that. Okay, and another idea is, so if I'm going to switch x and y's, okay, and I'm doing it for a function, now how many possibilities are there? Can I do it for every single x and y? Well, that's kind of crazy because there's infinite amount of x's that I can plug in here. Now, later on when we get into to square root functions, we'll talk about restrictions and limiting our domain, but there's an infinite amount of possibilities. So if I want to do this for symbolic form, and again, right here where it says symbolic form, if you're like, what the heck is symbolic form? Well, symbolic form is just an equation written algebraically. Okay, that's symbolic form. Okay, you have different forms of a function. You can see it visually, you can see it numerically with numbers, x and y coordinates. This is symbolically. Okay, so what are we going to do in this lesson? Well, here is the step process. Okay, so first thing I want to talk about is the inverse of a linear function is a linear function. A linear function can undo a linear function. And the domain of the linear functions is all real numbers. I can plug in any x from negative infinity to positive infinity. I don't have to worry about any types of restrictions. Okay, so what are the steps we're going to do? Step 1. Change the function notation to y, and all this is in this step is I'm going to take f of x, so if I have a function, or g of x, whatever its name is, and we're going to switch to y. Now the reason for this is step 2. Step 2, switch your x and your y values. That's it. Step 3, solve algebraically. You just want to solve it. Okay, and then step 4, we're going to change the y variable back to inverse notation. And remember, inverse notation, if our function was f of x, this is f inverse of x. Say it with me, f inverse of x, right? Okay, f inverse of x. Okay, all right, so let's go ahead and look at some examples. Here is the first one, and we're asked, find the inverse of each function, state the domain of the inverse in set notation. Okay, so step 1, I want to find the inverse. I gotta switch some x's and y's, so I gotta have some y's. Ha, by's, no, lame. Okay, so y equals negative 3x. Step 2, I'm gonna go ahead, I'm gonna switch my x and my y. Watch closely. X equals, okay, it was y, equals negative 3y. I switched x and y. That's it. All right, step 3. Solve for y. Okay, so I want to go ahead, I want to isolate y, so I'm going to divide each side by negative 3, divide by negative 3, and now we get y is equal to negative 1/3 x. Okay, that's almost it. We're almost there. Step 4, change it to function notation. So this was f of x, so this is going to be called f inverse of x. The function that undoes this function is negative 1/3 x. Same idea, right? When we asked you in Math 1 or foundational algebra, how do you undo multiplication? Division. How do you undo addition? Subtraction. It's the same idea. They undo each other. Example 2. Oh, sorry. Whew. I almost forgot the second piece here. So that's part, it's kind of like the first part. Part A. So here's your part A. Part B, state the domain of the inverse in set notation. Okay, and for linear functions, right, we said that the domain is all real values. So this is a linear function. So my domain in set notation, set brackets, is the x values such that, that's what that bar means, such that x is between negative infinity and infinity. Okay. And there you go. All right, next example. Find the inverse of this function, state the domain. So again, I'm gonna go ahead, I'm gonna make it y is equal to 2/3 x plus 4. Okay, that's step 1. Step 2, I'm gonna switch x and y. X is equal to 2/3 x plus 4. Some people will ask, Schoberg, can I just skip straight to step 2? Sure, if you can do that, right? The y and then switching the x and the y. Feel free to do that. But clearly I can't, right? This x is not supposed to be x. That's supposed to be y. Okay, so x equals 2/3 y plus 4. Step 3, now we want to solve for y. So if you ever get stuck here, if you ever forget to isolate y, you're doing order of operations in reverse order. So we're going to undo addition, subtraction. Okay, so we get x minus 4 is equal to 2/3 y. Now I want to isolate my y. So we'll multiply both sides by the reciprocal of the fraction. That's how you cancel fractions, right? I'm undoing division, so I multiply. I'm undoing multiplication, so I divide. Okay, and we have y is equal to 3/2. Whoa, look at that, that's cool. 3/2 x, okay, minus 4 times 3/2. So 3/2 times 4 over 1. Okay, and we just get 3/2 x minus, this is going to be 12 over 2, so that's 6, minus 6, okay? This is almost our answer, step 4. We want this to be in inverse notation. So our function is called g, so what do you think our inverse function is going to be called? G, inverse of x. G, I wonder, okay? So there's your inverse notation. Again, the last part, we need to state the domain. So the domain of our inverse is going to be the x values such that negative infinity is less than x, which is less than positive infinity. Another way of saying this is all real numbers. All real numbers, okay? The problem wants it in set notation, so yes, you have to do it this way, okay? But it's the same thing as all real numbers. All right, so those are the 2 examples. I have a practice problem here for you. I would like you to pause it. Do it. Did you state the domain? Okay, pause it, try it, and I'll post the answer here in a second. All right, so here's the solution. Okay, f inverse of x is equal to 1/2 x plus 4. Did you get it? Good job. So proud of you. Okay, domain, and then here is the second one. Next example. Okay, and here's the solution. All right, so in this video, we talked about finding inverses of linear functions. The inverse of a linear function is a linear function, and right, domain is all real values. You can plug anything into linear functions, anything from negative infinity to positive infinity. All right, so watch the next videos. We'll talk about quadratics and their inverse. We'll talk about cubics in the 3rd video and their inverse. Catch you next time. Work hard, be easy. Peace.